Hello, students, and I just wanted to do a quick run through as to what the lessons would be like, um, and give you a preview on the sets topic that we're going to look at. Now, again, visit cxc-exam.com, look for lesson notes, and then download the sets part 1, part 2. All right, and we're going to be looking at the part 1. Make sure you have this. It's very important to have the notes, that way you can follow as we go along. um, so the first thing I wanted to do is define what is a set. A set is a collection of things. All right, simply put, if you have um, if you have the numbers 1, 2, 3, 4, 5, that's a set. It's a collection of numbers greater than 0 and less than 6. Or you can say it is the set of the first 5 numbers greater than 0. Alright? But it's a collection of things. In this case, it's a collection of numbers from 1 to 5. Simply put. You can also say boys who play cricket. Alright? There are 18 boys in a class who play cricket. That is a collection of boys who play cricket. It's a collection of things. So that's what a set is. Alright? Now, when we're dealing with sets, there are some important terms to note. The first important term is the universal set. What is the universal set? Have you ever heard of the word universe? Universe is the single largest set there is. It consists of everything. Alright? Now, I'm not saying that the universal set is the universe, but in the same way that the universal set contains every single thing, I'm sorry, in the same way that the universe is the single largest set, when we're talking about a given group, for example, boys boys in a classroom, boys in Form 5, in Form 5. That's our universal set. That's the group of students who we are talking about. There are more boys in the school. There will be more boys in Form 1, 2, 3, 4, and Form 1 to 4. But we're not talking about those. We're talking about boys in Form 5. So when you're looking at the universal set, alright, universal set is pretty much the group of students that we're analyzing, or the group of people that we're analyzing. All right, it is represented by U, and on a Venn diagram, that's how you just that's this here, this rectangle in the Venn diagram represents that universal set. All right. Now, the other concept we wanna look at is subsets. Now, similarly to the universe, Alright? The universe contains galaxies. Alright? The universe contains galaxies. Galaxies contains solar system. Solar system contains a star. It contains a star. Or more than one star in some cases. And it contains planets. Alright? So, in a case like this, the galaxy is a subset of the universal set. The solar system is a subset of the galaxy, and so on coming down. So subset is the smaller set that is derived from your universal set. Alright? So let's look at this. Universal set is a set of all numbers from 1 to 5. Alright? And you want to know, and you want to find the subset of, let's go from 1 to 3. That might be too much. 1, 2, 3. And you want to find the subset of this universal set. You want to find all the sets that this universal set can contain. The first set that it will contain is itself, which is 1, 2, 3. The second set that it will contain is an empty set. Alright? And then it will contain a set of 1, 2, 3. Because all of these can be found in this. It will contain 1 and 2. It will contain 2 and 3. It will contain 1 and 3. Alright? So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 sets. Now, to know how many subsets you can derive from a given set, you use the formula 2 to the n power, where n is the number of elements in the set. In this case, you have 1, 2, 3 elements in this set. If you had 1, 2, 3a, you'll have 4 elements in the set. Alright? So however much number of elements you have in the set, that's your power. So it's 2 by 2 by 2, 4, 4 twos, 8. Which means that from this universal set, we can derive a number of 8 subsets. Alright? So let us recap what we have so far. Alright? We have the universal set, which is everything in the set. And then we have subsets, which can be drawn in this here. Alright? So the subset is a smaller set that can be found in the universal set. Alright? Let's see what else we have here. Now, we spoke about the empty set, which is the null set. It has no elements. Now, we want to do complement of a set. Alright? Now, the complement, let's say we have u equal 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright? And then we have A is equal to 1, 2, 3. B is equal to 3, 4, 5. Alright? And you wanted to know, or someone asks you, what is a complement? Complement is represented by this little one at the top. Alright? This little stroke at the top. Alright? The complement is everything that is outside of this set, but within the universal set. Alright? Everything that is outside of the set and in the universal set. So A complement, alright, is equal to what is not in A but in the universal set. That would be 4 and 5. So which means that the A complement in this case is 4 and 5. Okay? Now, so we were to draw this on a Venn diagram. U, and then we have A and B. A, B, we have 3 in the middle, 4, 5, and then we have 1 and 2. Alright? Everything that is outside of this circle would be considered as a complement. In this case, we have A complement 4 and 5. Now, what if the universal set had the number 6 inside? Alright? Then we put 6 out here because it is neither in A or B. It's not in A or B. Alright? It's outside. Therefore, we need to expand this to say universal set. A complement, sorry, now includes 6. Everything that is outside of set A. Anything that is outside of a set is the complement of that set. Alright? The next concept we want to look at is A union B is the union of a set. Alright, so when you think about a union, think about marriage, joining of two things, joining of two people. Alright? So things, things don't get married, but people get married, right? It's the joining of two people. You're getting married. So that's pretty much what union is. It's joining two sets. Now, coming back to our previous example, U equal to 1, 2, 3, 4, 5, 6. Alright? A equal 1, 2, 3. B equal 3, 4, 5, right? And you wanted to find what is A union B. That's how it's written. A union B. We want to join set A and set B. That's what we want to do. We join them by writing the elements of A. 1, 2, 3. Now notice 3 is also in set B. We do not write 3 again. Okay? We don't write 3 again. We write 1, 2, 3, 4, 5. A union B. Okay? You joined these two sets together to give you this. Represented on a Venn diagram. And we're in universal set. We have A, we have B. A union B is everything here. Everything in this circle. That's A union B. Alright? Joining them together. That's what you're doing. Now, the next concept is intersection. What is A intersect B? The intersect is pretty much where it meets. What is common between these two sets? Alright? What is common? 3 is common. So the intersect is 3. Represented on a Venn diagram. A intersect B. Alright? Now, there are some mix and matches that you can do with these concepts. Alright? You can mix and match. We talked about union, intersect, and we talked about complement. Alright? Now you can mix and match these. What do I mean by that? You can say A intersect B complement. Alright? And you could find that. You could find B complement. What is B complement? It is 1, 2, 3. I'm sorry, B complement would not be 3. It'll be 1, 2, and 6. Alright? B complement is 1, 2, and 6. And A is 1, 2, and 3. It means therefore that B complement or A intersect B complement is 1 and 2. See what we did there? B complement A intersect B complement. Represented on a Venn diagram. Is this. or you might say A only. All right. Now, A intersect B complement is not the same as A intersect B all complement. Okay? It is not the same. These two are completely different. In this case, you have to find A intersect B first and then find what is the complement of that. Alright? What is not in A intersect B. In this case, A intersect B is 3. Therefore, anything else that is not 3 will be A intersect B all complement. Follow? Alright, let me go that again. A intersect B complement. Right? We said that you find all the elements of A, B complement, what's not in B, and then find where what intersects. What is the same between those two? In this case, we're saying find A intersect B first, A intersect B, and then anything that is not in A intersect B. That's what this represents. Think you follow? Alright? So, on a Venn diagram, this will look like this. A intersect B complement. Okay? This is A intersect B complement. And here we have A intersect B all complement. That's everything outside of A intersect B. A intersect B all complement. That's how this is read. A intersect B all complement. See the difference? Visual representation of the difference. This is A intersect B. This is everything outside of A intersect B. This is A. This is everything else outside of A, and this is where A intersect whatever is outside of A, whatever is outside of B. That's the big difference. Alright? So, let's see. You have some exercises that you can practice, and go ahead and practice those. And like I said, you can mix and match these in a number of different ways. You can even go ahead and say, let's see what else you could say here. You could say A complement intersect B. You could say A union B complement, A union B all complement. Alright? So you can definitely mix and match how these, they probably, some of them you might find might end up back to be the same thing, but others might not. In this case, this is not. Alright? Just a quick preview, and I will definitely go back and review this again.